Hello everyone, my name is Ogenete Jirio Mamogo and you are welcome to Oakscam Academy. Now if you are new to my channel, kindly hit the subscription button below. Also like, share and of course avail yourself to the lessons so as not to be left behind. Welcome back. So in today's class, we're going to be learning about acids, base and salt. But for the purpose of this lesson, we're going to be focusing on acids. So let's get right into it. First things first, what is an acid? Now we have three definitions of an acid. We have a definition by Arrhenius, we have a definition by Bronsted-Lowry, and we also have a definition by Lewis. Now, Arrhenius defined an acid as a substance which produces hydrogen ions as the only positive ions when dissolved in water. Okay, then Bronsted-Lowry defined an acid as a substance capable of donating a proton. So in essence, Bronsted-Lowry defined an acid as a proton donor, while for Lewis defined an acid as an electron pair acceptor. So you see these three definitions of an acid. When you are asked on an exam or a test, you can give anyone, except it is specifically you are specifically asked to define acid according to, for example, Lewis. So remember I said Lewis defined an acid as an electron pair acceptor, and Bronsted-Lowry defined an acid as a proton donor, and Arrhenius defined an acid as a substance that produces hydrogen ion when dissolved in water. So these are the definitions of an acid. Now we have classifications of acid. An acid can be classified into organic acids and inorganic or mineral acids. So what are organic acids? Now organic acids can be defined as those acids that are derived from plant or animal sources. So they are derived from what? Plant or animal sources. Now examples of these types of organic acids include, we have ethanoic acid, which is gotten from vinegar. We have amino acid, which is gotten from protein. We have lactic acid, which is gotten from milk. We also have citric acid, which is gotten from limes and lemons. I know previously we were made to believe that citric acid is orange, but that is not true. Oranges are actually from ascorbic acid, which is your vitamin C. Then we also have fatty acids, which is gotten from fat and oil. So these are examples of what organic acids. Like I said, they are derived from what? Plant and animal sources. Then we have the inorganic acids, and inorganic acids are gotten from elements as mineral elements and inorganic matter. So that is where we get inorganic acids from. They are gotten from mineral elements or inorganic matter. And examples of inorganic acids include what we can find in our laboratory. We have our hydrochloric acid, which is our HCl, which is gotten from a reaction between hydrogen and chlorine. We also have our tetraazosulfate 6 acid, which is our H2SO4, and it can be gotten from the reaction of hydrogen, sulfur and oxygen. We also have HNO3, okay, which is gotten from hydrogen, nitrogen and oxygen, which is called nitric acid. So these are examples of what? Inorganic acids. Like I said, they are mineral acids, okay? They can be prepared in laboratory. So that is organic and what? Inorganic. Those are the classifications of what? An acid. Moving on, we have what we call strong acid and weak acids. Now what are strong acids? Strong acids are those acids that completely ionize in water to give hydrogen ions. So strong acids completely ionize in water to give hydrogen ions, and the hydrogen ions present in strong acids are of high concentration. Okay, so they have high concentration. And examples of acids under strong acids, we have your HCl, you have your H2SO4, you have your HNO3. These are examples of what? Strong acids. The concentration of the hydrogen ion present is very high. Remember I said they completely ionize in water. Then for your weak acids, they ionize but not completely. So you can define weak acids as acids that ionize partially in water to form or give hydrogen ions. So they ionize what? Partially, that is not completely. And examples of weak acids include your acetic acid, which is your CH3COOH. You also have your H2CO3 and so on and so forth. So those are your examples of what? Weak acid. I hope we understand. Okay, so moving on, we have, although it's not written on the board, we have concentrated acids and dilute acid. So I'm just trying to explain the different concepts under the topic acid. So we have concentrated acids and what? Dilute acids. So what are concentrated acids? These are acids okay, that contain more, these are solutions rather, that contain more acid than water. Okay, that's the word concentrated. It has more acid present than water. So that is to say, you are pouring a little amount of water into a large quantity of acid. That is what we refer to as what? Concentrated acid. And then for your for your dilute acid, this is when you pour small quantity of acid into a large container or body of water. So you have little acid poured into large water. That is what we refer to as what? Dilute acid. I hope you understand the difference. Okay, concentrated is what? Much acid, little water. Dilute is what? Much water, little acid. Now please take note, for the sake of safety, whenever you are preparing an acid in a lab, if you want to prepare dilute acid maybe for a titration experiment, please do not pour water into acid. Okay, it's very dangerous. What you want to do is that you want to pour acid into water. And in case you are wondering why, let me give an example. For example, let's say you are in your home, you want to have your bath, you have poured your hot water into your bucket, and you want to run the tap into it to mix it up. When you put on the tap and the water from the tap makes impact with the water in the bucket, what happens is that it's going to be a splash. Okay, and what is splashing? It is what? The hot water in the bucket. Now imagine that hot water in the bucket was the acid. You can see how dangerous that can be, and that is why we do not pour water into acid. We rather pour acid into water. I hope you understand. Okay, so please take note of that. That is a safety precaution while preparing dilute acid in the laboratory. So moving on, we have basicity of an acid. Now when we hear the word basicity, what we are talking about is the number of replaceable hydrogen ions present in a compound. So when we say basicity of an acid, it is the number of what? Replaceable hydrogen ions present in a compound. So I'll give you an example. Let's say we have HCl. Okay, now if we are to separate HCl into its respective ions, we have H plus and Cl minus. Okay, now how many hydrogen ions are present in this compound? One. That is to say, only one hydrogen can be what? Replaced, because we only have one hydrogen present. So this is what we call one or mono basic, because why? We only have one replaceable hydrogen ion present. Let me give you another example. Let's take H2SO4. So if we were to separate it into the respective ions, we have 2H plus and then SO4, 2 minus. These are the charges. Now, how many hydrogen ions are present here? We have 2. That is to say that we have 2 hydrogens that can be what? Replaced. So we have 2 replaceable hydrogen ions, and this is referred to as 2 or di-basic. I hope you are getting the hang of it. So even if it was H3PO4, 3 hydrogen, 3 or what? Tri-basic. Okay, so that's the concept of basicity, the number of replaceable hydrogen ions present in what? A compound. I hope you understand. Please feel free to leave questions in the comment section below. Also, if you have watched the video up to this point, give us a thumbs up, also subscribe. Okay, but moving on, properties and properties. Under properties now, we're going to be talking about the physical and chemical properties of an acid. So what are some of these physical properties? Number one, we know that acid is corrosive in nature, and corrosive means it has the ability to what? Eat through metal. So that's one of the most prominent properties of an acid. It is corrosive. That's one. 2, an acid is sour in taste. Now you may say, oh, how do you know an acid is sour in taste? Let's give an example. Remember, we have citric acid, which is a type of what? Organic acid. And citric acid is what? Limes and lemons. And we all know that limes and lemons are sour in what? Taste. Also milk. Whenever milk is going bad, one of the things we say is that milk is getting sour. Because why? It is lactic acid. So you see that acid has a what? Sour taste. That's one of the physical properties of what? An acid. Then another property is that acid can turn blue litmus paper red as an indicator in the laboratory. So acid will turn blue litmus paper red. So these are some of the properties of an acid. Okay, another property before I forget is that acid is an excellent conductor of electricity. So please take note of that. Acid conducts electricity. So these are some of the physical properties, although we have so much more, but for the purpose of this video, these are the ones I'm going to be giving today. Then for your chemical properties, the first one we're going to be talking about is the reaction with a base. Now, whenever an acid reacts with a base, two products are formed. Okay, so let's give the most basic equation for that. HCl is an acid reacting with a base. Let's choose NaOH. Now, whenever an acid reacts with a base, so this is our acid, this is our base, the product formed is salt plus water. So please take note, and this is what we refer to as a neutralization reaction. So a neutralization reaction is a reaction in which an acid reacts with a base to form salt and water. So this is one of the chemical properties of an acid. It reacts with a base. Then another chemical property of an acid is that acid reacts with metal. Whenever an acid reacts with a metal, hydrogen gas is given as a product. So for example, we have HCl, let's use HCl again, reacting with zinc. Now when HCl reacts with zinc, your product will be ZnCl2 plus hydrogen gas. That is even before we attempt to balance. So zinc now is our metal in this case, and this is our acid. Okay, so it doesn't matter what acid you are using or what metal you are using. Whenever an acid reacts with a metal, hydrogen gas is given off as a byproduct. Now I didn't balance this equation, but in our next video, or in a video we're going to be doing, I'm going to be teaching how to specifically balance chemical equations. But for the purpose of this class, it's just the equation I want you to focus on. So whenever an acid reacts with a metal, any acid, hydrogen gas is what's given off. Then another chemical property is that acid reacts with triazocarbonate 6. Okay, so these are some of the chemical reactions that acid undergoes. We have so much more. Okay, so lastly, we have the uses of acid. So what are some of the uses of acid? Number one, we know phosphoric acid is used in making or producing soft drinks. Okay, which we like our Coke, our Pepsi. Phosphoric acid is useful in that. Then sulfuric acid is used in the production of batteries. Okay, then H2SO4, which is also sulfuric acid, is used in explosives. It's also used like HNO3 fertilizers. Okay, production of fertilizers. Then we also know that acids, which is our citric acid now, is a good source of vitamin C. That's ascorbic acid. It's a good source of vitamins, vitamin C for the body. And these are just some of the uses of what acid. Okay, so please, like I said, if you have any questions, let me know in the comment section below. Also, if there's something I didn't mention in the video you want me to talk on, let me know in the comment section below. If you are yet to subscribe, kindly join our community, our channel. That said, I remain your tutor, Ogeneti Drew. Mama, have a wonderful day.